Hi, in this video, I will review correlation and regression. We begin with the problem. It states the following. A community college instructor wants to investigate whether there is a relationship between the number of hours students work per week and how many classes they miss. The instructor collects a random sample of 7 students and records the number of hours they work per week along with the number of classes they have missed. Using alpha 0.05, we want to see if there is correlation between the two variables. Step 1 is to draw the scatter plot. The X values are the hours worked per week. The Y values are the classes missed. So the first pair of data values is 10, 2. We would go 10 units to the right, up 2 units, and repeat that pattern. What we can see is that as the hours of work increases, it appears as if the number of classes missed also increases. So we want to test if there's correlation between the two variables. So to perform the test for correlation, H naught will always be rho. This is the Greek letter rho equal to 0. It represents the population correlation coefficient. Rho equal to 0 translates to there is no linear relationship. H sub 1 is rho not equal to 0. That translates into there is a linear relationship. To perform the test accurately, we need to find what's called, or we need to find the critical values. To do this, we compute degrees of freedom, n minus 2. N is the number of pairs. We originally have 7 pairs, thus 7 minus 2 is 5. We look up the critical values in our Pearson correlation matrix. Alpha is 0.05. We go down to 5, and the critical value is 0.754. There's actually 2 of them. There's a negative 0.754 and a positive 0.754. Next, we have to calculate the sample correlation coefficient, R. We can use a calculator to do this. In this case, I am using a TI-84 Plus calculator. Press that, and then edit. Enter the X values in L1. Enter the Y values in L2. Press Stat. Calculate. Go to option 8. Hit Enter. Make sure L1 and L2 are selected. For these 2 other items, there should be nothing there. And then just press Calculate. You'll see R is 0.898. R falls in the critical region, so we reject H naught. This means that there is a positive linear relationship. Now, the next part of the problem is to find the line of regression and then use it to make a prediction when a student works 50 hours per week. Think of the line of regression as a line that's closest to every single plotted point, and we can use it to make predictions. The format for the line of regression is y prime equal to a plus bx. A is the intercept, b is the slope. These are called regression coefficients. And we can find the line of regression coefficients in the graphing calculator. When we computed R, at the very top, we have the intercept and the slope. I typically round these to 3 decimal places. A is 0.857, B 0.143. The final step is to make the prediction based off the data that the instructor used. You put 50 in place of X, perform some algebra using order of operations, and we end up with 8.007, which we round to 8 days. Thus, a student would, in this class, miss 8 days if they work 50 hours per week. Now, the final step is to ensure the accuracy of your line of regression. So this entails calculating what's called the coefficient of determination, R squared. If we go back to the graphing calculator, we can see that R squared is displayed, 0.806. And we want to translate that into a percent. So it's 81%. This means that 80% of the results were explained by our variable X. We also want to calculate what's called the coefficient of non-determination. That's 1 minus R squared. So 1 minus 0.81 is 0.19, 19%. We want this value to be low and we want this to be high. Finally, we want to calculate the standard error of the estimate. We can do this using the graphing calculator, but we have to use a different function. So what we do in this case is we press stat, we go to test, and we have to go down to the function at level F. It's called the linear regression t-test. Hit enter, L1, L2, make appropriate changes here, and then just press calculate. Scroll down and we'll see S. That's going to be, we can round this to 0.83. So the standard error of the estimate is 0.83. And this basically helps us estimate how spread out are the original data values from the line of regression. And so what we can state is that the regression line fits the data well. Most of the variability is explained by the model. However, there are some individual predictions that vary from our average of 0.83 units. So we do have a little bit of spread around the line. But overall, it's a good model to make predictions. Hopefully this helps encapsulate all the key aspects of the test for correlation, computing the line of regression, and determining its accuracy. Thanks for watching this video.